Hello guys, welcome to this video. And in this video, we will be solving our question largest area histogram. So let me discuss the question with you guys first. The question basically says that we will be given an array. So suppose the array is 6, 2, 5, 4, 5, 1, 6. Okay. So this is the array that is given to us, and basically the question says that these elements of this array represent a bar chart. So I have drawn a bar chart for you guys right here. Okay. So these elements of this array will represent a bar chart, and these elements are the height of the bar chart. Okay. So the height of this is 6, the height of this one is 2, 5, 4. Okay. And so on, right? So all these elements of the array are actually representing the heights of a bar chart. And what we need to do is we need to find the largest area of rectangle that can be created in this bar chart, right? So let us see how we can do this. If I take this two as my base, what can I do? I can what is the largest size of rectangle that I can create using this 2 as my height, as my base. That is, I'm using this 2 as my height, right? So I can expand this rectangle from here to here. Now see, I can't go any further. I can't go any further because the next element is smaller than me. Okay, the sixth element is 1, right? Its height is 1, so I can't go any further. So for 2, the maximum I can expand it is from 1 to 5. That is, the width is 5. If we suppose that the width of every unit is 1, the width of this is a 1 1 1, then we can say that for 2 I can expand it to 5. Okay, and the height is 2, so the maximum area that 2 can give me is 10, right? Now let's move on. Let's see for 1. Okay, let's see for this 1 here. For this one, I can expand it from here to here, right? Because it is the smallest element. So the width will be 7 and the height is 1, right? Okay. Now let us say for this 5. See, for this 5, I cannot expand it anywhere, right? Because the next element is on the both the sides is smaller. So for this, the area will be 5 into 1. Okay. So I hope you guys understand this question. So now guys, let us discuss the solution approach of this problem. Okay. So as I would like to give a hint to you guys first that this question is very much similar to but we have solved already, next greater to the right. Okay. Now let us see how we can do it using the concept of next greater to the right. Right. See, what I told you guys in the question was that for every rectangle, for every bar of this bar chart, okay, for every bar of this bar chart, what I will try to do is I will try to expand it as much as I can, and I will return the maximum rectangle that can be formed by that bar. Okay, now let us try to do that. For this 6, can I expand it to this or this side? No. No. Why? Because on the left there is nothing, and on the right there is a smaller element. 2 is smaller, right? 2 is smaller, so I cannot expand this 6. So for this 6, assuming that width of every bar is 1, the area will be 6 into 1, right? Now coming to this 2. Now this 2 can be extended till here, but not any further because obviously there are no bars any further. And for this 2, I can expand it till here also. Okay, till here. So how many blocks are there? From 1 to 5, there are 5 blocks. So the width becomes 5 and the height is 2. Okay, so 5 cross 2. Okay, this 5 can't be extended on the left, neither on the right. But why? Because see, there is empty space here. Can I go here? No, because the next elements are smaller, right? Right. So the area is 5 cross 1. Now for this 4 can be extended from here till here. So 1 2 3 4 cross 3. Okay, now okay, let us move a little faster now. So now for this 5 again can't go anywhere, so 5 cross 1. For this one can be extended till wherever I want, right? Can be extended till wherever I want because its height is only 1, which is the smallest. So how many elements are there? 1 2 3 4 5 6 and 7, right? So 7 cross 1. Okay, now 7 cross 1 for this one, and for this 6 I can't expand it from here to here, nowhere, so 6 cross 1. Okay, 7 cross 1. So if I say, please listen this very carefully, if I say that for any given bar, say for this bar whose height is 4, I can only extend it till its left and right boundary, and the left boundary is actually nothing else other than next smaller element on the left, and the right boundary is nothing other than next smaller element on the right. So see, for this 4, what is the next smaller element on the right? This one, which is at the 6th index, right? So I can only extend it till here. I can't go to my next smaller element, right? Now, for this 4 again, what is my left boundary? This 2, because it is smaller. Okay, so I am saying for this 4, I can only extend it till my next smaller element on the left and next smaller element on the right. Okay, so that is why this is just a variation of next greater element to the right. So if you haven't watched this video, please go watch this video. This is a very important concept and it is being used in a lot of questions. Okay, and if you were not able to visualize what I just said, so let me draw another bar chart for you guys. Fast bar chart. Okay, without values. Okay, here you will be able to visualize everything. So let me try to draw a bar chart without values, just with heights. Okay, let us see for this bar chart. Okay, if I talk about this bar, can I extend it to my left or to my right? No, I can't, because it is an empty space, right? I can't go here. So for this bar chart, I can't go on the left or the right. Okay, because it was empty space. Or in other words, I can say that the next element to this bar on the left is smaller to it, and the next element on the right bar is smaller to it. So how far I can extend? I can only extend till my next smaller element on the left and on the right. Okay, now let us see for any other bar. See for this one. Okay, for this one, I can extend it till here on the left side. Okay, and till here on the right side. Why? Because for this element, the next smaller element on the left is this one, next smaller element on the left is this one, and next smaller element on the right is this one. Okay, so I hope the concept is clear to you guys now, that my left boundary will be next smaller element on the left and right boundary will be the next smaller element on the right. Okay, so now you see, the problem with this approach is that if you find next smaller element for this 6, you will need to use a for loop, right? Next, for using a for loop, we can find the next smaller element of this 6 on the left and on the right. But I need to find the next smaller element for every element in this bar, right? Every element. So I will need another loop. Okay, I will need another loop to find it for every element. So the complexity will become O of n square, O of n square. But we somehow need to do it in O of n. For this, we use stack, and this is where the video of next greater to the right will help you guys. So please watch it out, how we can find the next greater element of on the right or left you in O(n) time complexity, right? For every element in there. So here we will need to find the next smaller element to the right and to the left, and using stack we will find it in O(n) complexity. Okay, so now let me move to my code editor and let us see how we can solve this. Okay, so here we are. We have our array, and I told you guys that I will be needing a right boundary. That will be my next greater next smaller element on the right. Sorry if I say greater sometime, I'm just fumbling because there are so many questions with this same approach. Okay, so this is my right boundary and left boundary. So this will be basically next smaller element to the right, and this will be my basically, okay, next, sorry for that, next, this will be my next smaller element to the left. Okay, next smaller element to the left. Okay, now How we will find this, we will see later, and I'm not going to discuss it in very depth. If you want to understand it, go please watch the next later element to the right. Okay, so now for how are we going to calculate our area? So we will iterate through our array. What is our array holding? Our array is holding the heights of every bar of the bar chart, right? So I will iterate through my array, and what will be my height? My height will be ARR of I. Okay, because it is storing the height. So for the first element, the height will be ARR 0, right? Now, how will I find my width? I will find my width using my left and right boundary. What is my left boundary? The next smaller element on the left. What is my right boundary? The next smaller element on the right. So how will I find it? L next smaller on the right. So right boundary minus my left boundary minus 1. Why minus 1? Because 0 based indexing. Okay, so what is my area? My area is basically height into width, right? Height into width. Okay, now I will create a max area variable. Why? Because I only need to print the maximum area. Okay, so I am creating a max area variable, initializing it with 0, and if my area ever becomes greater than my max area, that means I need to update my max area, right? Max area equal to area, and coming out of this loop, I can simply print this system.out.println max area. Done, right? So I hope this code is understandable. All I did was for the complete bar chart, what I did is for every element I found the, okay, let's talk about this. Okay, for every element I found the next smaller on the left, next smaller on the right and left. Okay, which was their left boundary and right boundary. Using the left and right boundary, right minus left minus 1, I calculated the width, and the height is already given to me. So using width and height, I calculated the area in this loop. Okay, so this much is done. Now let us see how we can calculate the right boundary. Okay, so I am saying for calculating the right boundary, you will need to iterate the array from left. Okay, right now just believe it, I will show you it in the diagram. Okay, so I have created an array. Now I told you guys I'll be needing a stack, so let me create a stack. Integer st equal to new stack, and okay, so now that we have our stack, what we need to do is, if I say, look at this bar chart, right? So for this element 7, right now what we are trying to do, we are trying to find the right boundary of every element, right? So for this element 7, will there be any element smaller than it on its right side? Obviously no. Obviously no, because this is the last element on the right. Okay, so for this element I can already say that the right boundary right boundary for the n minus 1th element will be n, right? What does this mean? So I basically said that for the 7th element the boundary will be 8, which is nothing but array length. Okay, so this is just a way of indicating that there is no element to the right which is smaller to it. Okay, so having said that, now let us move forward. So what I will do is basically I will push this index st dot push in my stack. Okay, so I will push n minus 1 in my stack, and I will start a for loop. Okay, I will start a for loop for int I equal to 0. Okay, no, so we are starting from here. Okay, we are trying to find the right boundary, so we are starting from here. So we will start from n minus 1. So my loop will start. I have already completed my work for n minus 1. So I have already done my work for the n minus 1th element. So we will start the loop from n minus 2. What I'm basically trying to do in this loop is from the last, that is from this 7, for coming back 2, 6, 5, 4, 3, 2, 1 for trying to find the right boundary for every element. Okay, so let's move on. Let's move on. Okay, so I started a loop from n minus 2, I is greater than 0, I minus minus. Now, what I do is I do three things. First, I check, I start a while loop and I check if the element at stack.peak is greater than or equal to me. Okay, if this is the case, I simply pop that element out. Okay, I simply pop that element out. Now I will also check stack.size is not equal to stack.size is not equal to 0. Okay, why this? Because here I'm trying to peak the stack, so if the stack will be 0, we will get an error. Now that we have popped everything, what will I do? I will create my answer. So if I know that if you haven't watched the next data to the right, you might not be understanding this right now, but we will do a dry run and everything will be clear. Okay, so see, if stack.size is not equal to 0, so my right boundary is whatever is lying at the peak of the stack. Okay, so my right boundary is whatever is lying at the peak of the stack. Okay, and if this is not the case, then my right boundary is what we already discussed, that for the elements whose right boundary does not exist, we say it is array length, that is n, and at the end I push myself in the stack. Okay, so our work for the right boundary is done. So let me take this code to my whiteboard and let's try to dry run this. Okay, so let me put it somewhere here. Okay, yeah, fine. Expand it a little bit and erase this. Is this okay? So now what I basically did was I created a stack. Okay, so for finding the next smaller to the right, we are doing this. Okay, so I basically created a stack and this stack will be storing some indices. Okay, so this is my stack. Now see here, I created an array right boundary. Okay, so this right boundary array is storing the next smaller element to the right for every element in this array. Okay, for every element in this array, this right boundary is storing the next smaller element on our right side. Okay, so I said for the seventh element, there will be no next smaller element to the right. Why? Because it is the smallest. Okay, so for 7 I stored n, which is just indicating that there is no greater element on its right. Okay, and I pushed the 7 in my stack. Okay, so the seventh element was 6 actually. Okay, so here actually I pushed my index, but right now I am pushing here the values. Okay, if I write the index here, this will be 0 based indexing, so this will be my array. So for the sixth index, right now forget this, I just wrote this to explain you the question. Okay, so this will be my indexing. Now I'm saying I pushed my sixth index in the, okay, and what was lying in the sixth index was value 6, so index is also 6. So okay, now I came inside this for loop. Okay, this work for this element is already done because we know there is no next smaller to the right. For this one, what we will do is we will do basically three things. First is pop, second is build my answer, and third is push myself. Now, how will this work? So for one, I will check what is lying in the stack. Is it greater than me? Yes, for now it is greater than me. So I will pop it out. Okay. Now, is it greater than me? Yes, it is greater than me. So pop it out. Now, what is my answer? Is there anything lying in the stack now? No, there is nothing lying in the stack. So my answer is again n. That means there is no smaller element with of which is on my right side. Okay. Now, what I do? I push myself. So I pushed 1. Right. Now, I came to this. 5. Okay. So what 5 did? Again, it checked, is the element in the stack is greater than me? No, it is not. So what I did is no popping. Okay, because it is not greater than me. So what is my answer? The element lying at the top of the stack is my answer. So for 6, the answer was, okay, let me write the indexing here. 0, 1, 2, 3, 4, 5, 6. So for sixth index, the answer was 7th because there is no next smaller to the right. Okay, for 1, the answer was sixth index. For 1, the answer was sixth index. No, for 1, the answer was again 7 because there is no next smaller on the right. For 5, the answer will be fifth index. Fifth index because at the fifth index, that is at 1, the next smaller element to the right exists. Okay, so what I did was I got my answer. Now I will push 5 in this stack. Okay, so push 5 in the stack. Now I come to 4. So what will 4 do? 4 will check, is there something lying in the stack that is greater than me? Yes, pop it out. So it popped it out. Now what is my answer? Whatever is lying at the top of the stack is my answer. So for 4, the next smaller element is 1. Okay, so for 4, the index, I'm storing here the index. So 5 at the fifth index, the next smaller element to the right is lying. Okay, so if I say, are you understanding what I am trying to store in the stack? What I am trying to store in this stack is the next possible answer. And when I say the next possible answer, what I basically mean is the possible answer for elements on my left. Say, for one, I am storing the possible answers in the stack. That what are the possible numbers which can be the smaller element on my right. That is why I am popping out all the elements which are greater than me from the stack. So for C, for this one, for this one, can 6 ever be the next smaller element? No. For all the elements on its left, can 6 ever be the next smaller element? No, 6 can't be. Why? Because 6 is greater than this one. So if 1 is not smaller than them, will 6 ever be smaller than them? No. That is why I was popping every element that is greater than me out of the stack. So our work is very simple. Just pop all the elements that are greater than me. If the stack has something, then the peak of the stack is my answer. If it does not have anything, then n is my answer, and then simply push myself in the stack. Okay, so now let us move and write the code for next greater element on the left. Okay, so I am saying for left we will start from 0. For right we started from n minus 1. Now we will start for 0 for left. Okay, so we will create our stack. Okay, the left boundary. Now left boundary for the 0th element will be -1. Why? Because the 0th element is the first element, so there is no element smaller to it in the left, so -1, right? And now I will push my 0th index in the array, right? And this loop will start from 0 till n I plus plus. Now everything will remain same, except I will change this left right boundary to left boundary. And for the elements whose next greater to the left does not exist, the answer will not be n, but it will be -1, right? So I will change this n to -1. Okay, so this is our code. Now let us see how it works. Okay, so okay, I have a compilation error at 25 while stack dot size is not equal to 0 and array of it is saying cannot find symbol ARR. Okay, the name of the array is A here. That is why it is giving a compilation error. Right? Okay. Variable peak at 25. Okay. So I have some errors here actually. So I can just, okay. I forgot to put brackets after peak. Right. Dot push. Okay. So I forgot to put I here. So push your index in the stack, right? Push cannot be empty, obviously. Okay, accepted and submitted. So guys, let us see first if it submits or not. Interesting. Okay, correct answer. So guys, that was all for this video. If you like our videos, please subscribe to Pepcoding. Thank you.